Good day! I am Malunes.
And I am Mejia.
And I am Rosales.
And for this video, we are going to talk about steam turbine construction, which consists of
The components.
material selection.
And safety devices.
1, 2, 3,
Let's
G!
The component of a steam turbine. The major components that constitute a steam turbine are casing. The casing should withstand all normal and emergency service load and allowable peeping forces and movements caused by temperature change. The design of the turbine casing design should be such that thermal stresses are minimized. Adequate support must be provided to the steam turbine casing to maintain good alignment with the rotor. Nozzle. Nozzle is a duct of passage of smooth, varying cross-sectional areas which converts heat energy of steam into kinetic energy. Rotor. Rotor. This is a main component in a steam turbine that carries the blades to convert thermal energy. Blades absorb the energy of high steam velocity and convey into the rotor. The shape of blades significantly affects the turbine performance of turbine and requires high reliability. Governor for speed control. Governor, a steam turbine. Governor is a component of the turbine control system that regulates rotational speed and responds to changing load conditions. Servo mechanism. Servo system is designed to control the converting valves of the steam turbine precisely and quickly respond to loss of load or emergency. Oil pump for lubrication. Oil pump is used in large turbine system to prevent metal-to-metal contact in the bearing during turbine start-up.
The selection criteria are based on the type of steam turbines. Depending on the purpose, use, required output, location, arrangement, and circumstances, appropriate type of steam turbine should be selected. Condensing steam turbine. As for selection criteria, first, when only electricity or power required. Second, when cooling water to condensate exhaust steam is available. It is used for machine drive, geothermal power, heat recovery. Next, regenerative steam turbine. First, when small and middle output and high efficiency is required. Second, when cooling water to condensate exhaust steam is available. It is used for power generation for cement, ironworks, and mine. Next is reheat steam turbine. First, when large output and high efficiency is required. Second, in general, it is used as regenerate and reheat turbine. It is used for large-scale power generation. Next is back pressure steam turbine. First, when the large amount of utility steam of a type is required. Second, it is necessary to operate electricity and steam in parallel due to excess and deficiency between generated electricity and power demand of plant. It is used for private power generation, machine drive, cogeneration. Next is extraction condensing steam turbine. First, when the large amount of utility steam of one or more types are required. Second, when the power demand is less than the amount of utility steam. Used for private power generation, machine drive, cogeneration. Next is extraction back pressure steam turbine. First, when the large amount of utility steam of more than two types are required. Second, it is necessary to operate electricity and steam in parallel due to excess and deficiency between generated electricity and power demand of plant. It is used for private power generation, machine drive. Next is mixed pressure steam turbine. First, when only electricity or driving power is required. Second, when it is necessary to collect low pressure steam. Third, when it is capable to get cooling water for condensation of exhaust steam. Used for private power generation by heat recovery, machine drive.
Turbine protective devices. Tripping device. Whenever the turbine is to be tripped, the governing oil pressure is drained by the tripping device. Overspeed trip. The overspeed protection is formed by the three independent sensors of the turbine speed evaluation that act through a selection of the output signal 2 of 3 after exceeding a set value of security speed for an immediate impulse for closing of the ESV within less than 30 ms. Magnetic pickup. A magnetic pickup consists of a permanent magnet wrapped with a coil of a few thousand turns of fine enamelled copper wire. Next is the proximeter. The mechanical energy is transformed into electrical energy by using the proximity transducer system. The interface device used for this system is called a proximeter. Next is the case expansion. Case expansion is the thermal growth of the machine case as it expands during machine startup and online operations. Rotor expansion. On a turbine is the absolute measurement of the rotor's actual thermal growth with respect to the turbine's foundation. Next, differential expansion. This is very important parameter receiving much attention during turbine startup and warming. This parameter measures how the turbine rotor expands in relation to the turbine shell or KC. Next is key phaser, a transducer that produces a voltage pulse for each turn of the shaft, called the key phaser signal. It produces a voltage pulse once each revolution. Rotor axial displacement. Two types of trips: rotor axial displacement and radial vibration. Bearing temperatures. Temperatures of bearing is a measure of how hot a bearing is operating. Generator protection, bearing and winding temperature, earth fault protection, reverse or low forward power, over voltage or under voltage, over frequency, under frequency, over current, differential, neutral displacement, negative phase sequence.